Greetings everyone. Today we have a new product to review for you from Douk Audio. Make hi-fi affordable. Knob sound. So what do we have here? A5 advertisement. Okay. Let's pop this open and see what we get here. Okay, we get a power supply, manual, and an amplifier. Let me unbag it here. And here we go. Oh, we get a little window in the top. You can see all the goodies inside. I don't have to take it apart. I probably will anyway, but I wonder if it has bling bling lights. What's this? Warm tips. Okay. No high voltage inside, but don't open glass window during working. Yeah, I don't like to be open during working either. Okay, so we have a volume control. Oh, there's a switch. And on this side we have 30 hertz off, 200 hertz. So this is like an adjustable filter here. So is it, you can use it as a subwoofer amp or the high pass for the left and right speaker. Interesting. I'll have to RTFM. Read the fine manual. We have the audio in, we have an auxiliary out speakers, and the 24 to 48 volts. And a little vent in the sides of the case. That's good to see. Okay, I RTFM'd, and this is a high-pass filter control. And that's kind of handy because a lot of the main speakers you use in the subwoofer system, you know, they're kind of small, and if you like to crank it up, you know, those little speakers, the sound can compress, especially with the bass. And, you know, it could be pretty stressful if you really like to crank it up. So controlling the amount of bass that gets to those speakers can be beneficial. And then you can use a subwoofer amp, control that bass for the crossover, and, you know, let those lower frequencies go to the subwoofer. So yeah, that's kind of a neat thing. I've not seen that before. And we'll take a look at the response of that control on the Quantasylum. Here's the specs. Of course, we got the usual 300 watt claim, and we know that we don't quite get there. What are they giving us here? They're giving us a 32 volt supply. So, yeah, around, I don't know, 50, 60 watts into 8 ohms, and somewhere around 90 watts into 4 ohms. You can also purchase a larger power brick, the 48 volt one. And if I recall, with the TPA 3255 bass amplifiers, you could get just under 200 watts into 4 ohms. I think it was like around 190 watts. Oh yes, we got the little bling bling lights in there. They're not super bright or anything. And it's kind of a subtle color effect, and you can change the color with the dip switches in here. So I can get my, see, I got them off so you can turn the greens on here. So yeah, you got green. You can put blue. Ooh, I like a kind of an aqua color there. I think I'll leave that on. Okay, for our kickoff measurement here, where I measure it at 1 watt into 8 ohm loads, 1 kilohertz, just to see how things are going. Very excellent. 0.00, just about 0.006. Checking the amplifier's gain with the volume control wide open to get that measurement is 26.3 dB. That's about 20.6 times gain, so if you're putting 1 volt in, you get 20.6 volts out. So if you're using the higher voltage supply, you might struggle to reach clipping with a 1 volt signal. So gain might be a little bit on the low side, but with the lower voltage supply, you're almost right there, because your peak output voltage would be around 30 volts or so. Now, to properly measure a Class D amplifier, you really should use a filter going into the analyzer to remove the garbage above the audio spectrum, 20 kilohertz. Might even bring the distortion number down. One reason why I don't do distortion plus noise is, for that. Plus, there's a lot of AC noise getting in. I can't blame the amplifier here. It's probably my setup. Really need a noise-free environment to measure that, and it takes a lot of effort to get that in my setup here. Frequency response is flatter than flatty flat. I mean, here's 1 dB down, and it's just all the way down, well below 10 hertz, and up here at 20K it is, stone flat, and it starts rolling off due to the output filters. See, we're 1 dB down here at 20, 30, a little over 40 kilohertz, so that's the output filter starting to roll off the signal. As far as the audio spectrum goes, this thing is just flat. Audiophile, perfect flat. Frequency response at 4 ohms. It's really flat in the bass region. We're starting to roll off here. We're less than 1 dB down at 20 kilohertz. That would be 0.8, minus 0.8 dB. And at 3 dB down, we are probably 36 or so kilohertz. So not quite as flat, but at such high frequencies most people can't hear. Okay, so now I have the high pass filter function enabled, set to 30 hertz, and it's doing exactly what it's supposed to do. See, at 30 hertz for 3 dB down. So yeah, it's well designed, doing its job. We do have an overshoot. This does seem to be a high order filter. Look how rapidly that drops off. So we do get about a half a dB of overshoot with the filter before it gets back flat. When doing these measurements, I make sure to set the FFT to a higher value. When you're looking at low frequency activities, it's good to set that high. Okay, so now I set the control to the 200 hertz cutoff position, and it's really close. That's the 200 line, and it's just a little bit over. No overshoot, so it depends on the topology of that filter circuit they've used in there, how that works. But it does seem to be behaving like a lower order filter with this curve here. Output power versus distortion. Red line is the 4 ohm load, blue line is the 8 ohm load. What's interesting is the 4 ohm load is actually very slightly less distortion than the 8 ohm. Almost load invariant in this region. At very low powers, distortion is extremely low. We're down, close to the 0.001% 98% range, which is extremely good. However, as power increases, the distortion increases. I'm used to seeing more of a flat line with solid state amps, or I should say linear type amplifiers, and then they kind of curve north when they get near clipping. But this is more of a gradual rise. At 8 ohms, you can see here there's not really a defined clipping point, it's just a gentle curve upwards. And we're hitting 20 watts at the 0.1% line and about 31 watts with the 4 ohm load. And we hit the 1% line at 40 watts and just shy of 90 watts with the 4 ohm load. Frequency versus distortion. Well, at lower frequencies, it's very good, dipping below the 0.01 line here in this region, just below 1 kilohertz. But beyond that, it's a steady increase in distortion, crossing the 0.1 line at around 5 kilohertz, and then increasing up to 20 kilohertz, which at 8 ohms is actually a bit more, at I'd say about 0.7%. 0.5% for the 4 ohm load. You know, that's not really a good spec sheet number, but can you hear that? Well, the harmonics at 20 kilohertz is going to be 40, you know, the second harmonic, so that's not going to be audible. So it's debatable if you can really hear this, but like I say, it doesn't look that good on a spec sheet. But the more important range is the distortion is very low. Quick gander at the circuit board. We have power coming in, 3300 microfarad, 63 volt main filter capacitor. We have a little power supply section that develops the positive and negative rails for the op amps. Some op amps here, probably for the filtering function. We have a microcontroller, I believe that is, because when you turn it on and when you turn the filter on, you can hear some relays clicking. So it needs some sort of control for that. We have the pluggable op amps if you want to change them out, probably buffers for the main power amp stage. I'm measuring around 7K of input impedance or resistance. Another relay here, another one over here. Which we have the output chokes and capacitors. On the flip side of the board, we have the 3255 Class D power amp chip. Mounted to that chip is a large spreader. I'll have to put some new grease on there, which is in contact with the bottom of the casing here to help dissipate the heat. Now this is not a real large case, so now I'm not sure I would run this with the 48 volt supply, especially if you like to crank it up, because even being Class D, it has to dissipate heat, and it's not a really large amplifier, it's kind of small. So. Alright, I'm going to put it back together and hook it up to some speakers. Okay, I set it up over here where I have some room. These speakers are just kind of too big. Get the little amp there sitting between the speakers. You can see the bling lighting set for like a cyan color. Turn some music on there. Okay, got the high pass filter set for 200 hertz. See, it takes the bass out. Turn that down. Turn that off. There you go. So, what do I think of the Douk Audio A5 amplifier? Well, I really like the warm tips. It's good to have warm tips. I like this function with a high pass filter, so you can dial the main speakers in with your crossover if you're using a separate subwoofer and subwoofer amplifier. Sounds good to me. During the listening test, I didn't notice any issues. Noise is very low, no issues there. Has very low bass response, way out into the single digits. So if you want to use it with those tactile bass transducer units, you have that. Or if you're building some extremely low frequency subwoofers, it's more of a tactile, feeling the bass rather than hearing it because of that frequency, but it goes very low. Compact size, it has the little window in the top with the bling LEDs. Yeah, just an added touch you might like. What about the cons? Well, for the spec sheet type people, distortion performance wasn't perfect. I always like to see amplifiers produce below 0.1, and it did very well at lower powers. But at higher frequencies and at higher powers, you saw that distortion increase, as we saw in the test results. I would also stick to the 32 volt supply they give you rather than going with a 48, because it is a pretty small amplifier and it'll get really hot if you're going to push it with a higher voltage supply. Beyond that, I give it my recommendation, and I thank you for watching.